You may heard about the term convolution. Here we have an image and a kernel. This kernel is designed for sharpen an image. In this video, we want to talk about the best intuition about the convolution. Actually, the best intuition about the convolution lies in the middle school math. What I mean exactly is the cross product between two polynomials. If you remember, we choose one of those polynomials and go through each of those statements in the polynomials and do the product. And then we add them all together to get the final result. Here is an example of convolution. Here we have an image. We add a padding of 0 around it. And also we have that sharpen kernel, which is red here. What we do in convolution is that we go over the squares that are the same size as our kernel in the image. We go through all of them. For example, we choose the first square that has the same size and bring that to do the operation. Then we go over each cell in the kernel and that square that we get from the image. Then we do the product of them and we sum over them. Here we have a lot of 0 and I'm going to skip them. So we have a multiplication of 5 and 0.1 plus minus 1 and 0.1 plus minus 1 and 0.1, which is equal to 0.3. So I put that answer in the output cell, which is a 4 by 4 here. Actually, we have 16 squares that are the same size as our kernel in the main image. So we have 16 cells in the output. And so the next square. Here we have symmetric image and symmetric kernel. So we can put the other values like what we have computed before. We do the same math for the middle square and put that for the other cell around it because of symmetry. Now let's take a look at that example about polynomial cross product. We first choose one of those polynomials and then start to roll it over the other polynomials. We do the product like the convolution. Here 10 times 5x to the power of 2 is 50x to the power of 2. So we continue this process. As you expect, we sum them together and the result is the same as that cross product that we had seen so far. The classic notation for these kind of things are the discrete signals. The discrete signals define on the natural numbers into the real numbers. Here you can see an example. The x of 2 is 1, x of 1 is 2, and x of 0 is 1. Okay, until now, we find out that the convolution and the polynomial cross product are actually the same concept. So, we know that there are some algorithms developed for the polynomial cross product. For example, the parallelism algorithm. And the question comes to our mind is that could we use the same algorithm for the polynomial cross product and use that for the convolution as well? The answer is yes. You may heard the FFT algorithm, which stands for the fast Fourier transform. We input two continuous signal here to the FFT, and then we do the element-wise product of them. And what we do is that we find the inverse of that FFT transform, which gives us the convolution. And you know, this reduces the complexity time of the cross product algorithm from n square to n log n.